morning children. In today's class from Unit 1 Metallurgy, we are going to discuss similar to thermodynamic principles, electrochemical principles also find applications in metallurgical process. The reduction of oxides of active metals such as sodium, potassium, etc. by carbon is thermodynamically not feasible. We saw already. Such metals are extracted from their ores by using electrochemical methods. In electrochemical method, the metal salts are taken in a fused form or in solution form. Yes, in electrochemical method, that is in this technique, the metal salts are taken in a fused form or in solution form. Then the metal ion present in the solution is reduced to metal by treating it with some suitable reducing agent or by electrolysis. Yes, so what is electrochemical process? In electrochemical process, the metal salts are taken in a fused form or in solution form, and the metal ion present in it is reduced to metal by treating it with some suitable reducing agent or by electrolysis. During chemical process, there is a change in Gibbs free energy. So, the Gibbs free energy change for the electrolysis process is given by the expression delta G naught is equal to minus NF E naught. Yes, the Gibbs free energy change for the electrolysis process is given by the expression, that is delta G naught is equal to minus NF E naught. Delta G naught, standard Gibbs free energy change. Then N, number of moles of electrons involved in the reduction process. Then F is the Faraday. It is the unit of electric charge. Okay, children. Yes, the quantity of electricity transferred in electrolysis per equivalent weight of an element or ion is equal to about 96,500 coulombs and is called as Faraday. Understand, children? Yes, Faraday is the unit of electric charge. Okay, there is 1 Faraday is equal to 96,500 coulomb. Then E0 is the electrode potential of the redox reaction. That is, a reduction of metal oxide is a redox reaction. We know most of the chemical reactions are redox reactions only. So, E0 is the electrode potential of the redox coupled reaction. Understand, ma'am? About electrode potential, we are going to study in Unit 9. If E0 is positive, then the delta G is negative and the reduction is spontaneous. We know if delta G is negative means only, yes, the reduction is spontaneous. Okay, when delta G naught or delta G will be negative means if E0 is positive. Understand, children? Yes, if E0 is positive, then the delta G is negative and the reduction is spontaneous. And hence, a redox reaction is planned in such a way that the EMF of the net redox reaction is positive. Understand? Yes. Then, when a more reactive metal is added to the solution containing the relatively less reactive metal ion, means the less reactive metal ion will be precipitated and the more reactive metal will go into the solution. Yes, we know when a more reactive metal is added to the solution containing the relatively less reactive metal ions, means the less reactive one, okay, will get precipitate and the more reactive metal ion will go into the solution. Understand children? Yes. So for example, when copper, okay, when copper metal is added to the solution of, yes, silver ion means, for example, silver nitrate. Okay, yes. Here, silver is the less reactive one, whereas copper is more reactive one. So the more reactive copper will display or will precipitate, okay, yes, the Ag plus ion of the silver solution. Understand children? Yes, the more reactive copper will precipitate the less reactive silver ion. Okay, yes. So the equation for the precipitation reaction or displacement reaction is Cu plus 2Ag plus gives, yes, Cu2 plus 2Ag. Here copper is more reactive, so the more reactive copper will display or will precipitate Ag plus ion of the solution of silver. Okay children, into silver metal. Clear? Yes. Similarly, when zinc, okay, yes, when a zinc metal is placed, yes, in the solution of copper, okay, in the solution of copper or in the salt solution of copper means the more reactive zinc, okay, yes, will precipitate the copper and the zinc ion will go into the solution. Understand children? Yes, it will be present in the aqueous solution, that is the zinc ion. Okay, yes. So the equation is Cu2 plus Zn gives Cu plus Zn2 plus. Now we are going to see electrochemical extraction of aluminium by Herald process. Electrochemical extraction is one of the application of electrolysis. The materials needed for electrolysis are electrodes, namely anode and cathode, then electrolyte. Anode, positive electrode. Cathode, negative electrode. Then the electrolyte should be the salt of the metal. Understand children? Yes, the electrolyte should be salt of the metallic ion. Understand? So in this method, the electrolysis is carried out, okay, in an iron tank lined with carbon, okay, which acts as cathode. So here the cathode is iron tank lined with carbon. The electrolysis is carried out in the iron tank. Understand children? Yes, iron tank lined with carbon is the cathode. Then carbon blocks is the anode. Yes, the anode is carbon blocks. Understand ma? Yes, a number of carbon blocks are immersed in the solution of electrolyte. Yes, the electrolyte used for the extraction of aluminium is, there is alumina. Okay, yes, 20% solution of alumina obtained from bauxite ore. Okay, yes, the pure alumina obtained by purification of bauxite ore by leaching is used. Understand children? In Herald process, aluminium is extracted, okay, from the pure alumina obtained by the purification of bauxite ore by leaching. Clear? Yes. So 20% solution of alumina obtained from bauxite ore is mixed with molten cryolite. Okay, yes, here the molten cryolite is added to 20% solution of alumina to lower the melting point of alumina. Okay, there is alumina solution, and to increase its electrical conductivity. So the purpose of adding molten cryolite is to reduce the melting point of the alumina and to increase its electrical conductivity. Then 10% solution of calcium chloride is also added. The purpose of adding calcium chloride is to lower the melting point of the mixture. So the electrolyte is the 20% solution of alumina obtained from bauxite ore, molten cryolite, and 10% calcium chloride. Understand, children? Yes. Then the electric current is passed between the electrode, means electrolysis will take place. Yes, iron tank lined with the carbon is the cathode. Then the carbon block acts as anode. Yes, listen children, number of carbon blocks are immersed in the electrolytic solution. Understand? The electrolytic solution is taken in the iron tank. Understand, ma'am? Yes. The temperature of the electrolysis is maintained above 1270 Kelvin. Understand? Yes. Now we can see the chemical reaction involved during the process. First, the alumina will undergo ionization. Okay, ma? Yes. The alumina will undergo ionization. Alumina formula is Al2O3. Yes. Here the alumina is ionized into aluminium ion Al3 plus ion and oxide ion O2 minus ion. O2 minus ion. That is the charge of the ion is, that is oxide ion. Okay, the charge of the oxide ion is 2 minus. Okay, children. Yes, alumina is undergoing ionization and ionized into aluminium ion Al3 plus ion and oxide ion O2 minus ion. The charge of the aluminium is 3 plus and the charge of the oxide ion is 2 minus. Okay, ma? Yes. So the balanced equation for the ionization of alumina is Al2O3 gives 2Al3 plus 3O2 minus. Let it be equation number 1. Then generally during electrolysis the ions are moving towards oppositely charged electrodes. Yes, during electrolysis the ions are moving towards oppositely charged electrode. Okay, children? Yes. So during electrolysis the positive ion, okay, yes, the positive ion move towards, okay, negative electrode. Yes, the positive ion move towards negative electrode. Yes, negative electrode is called as cathode, isn't it? Negative electrode is called as cathode. Okay, yes. So during electrolysis the positive ion is moving towards cathode. Since the positive ion during electrolysis moving towards cathode, the positive ion is called as cation. The positive ion is called as cation. Cation means positive ion. Okay, children? Yes. Then cathode means negative electrode. Yes, cathode means negative electrode. Yes, cation means positive ion. Understand? Yes. Similarly, the negative ion, okay, move towards positive electrode. Yes, the ions are moving towards oppositely charged electrode. So the negative ion is moving towards positive electrode. Positive electrodes are called anode. Okay, yes. So during electrolysis the negative ion is moving towards anode. Okay, yes. That's why the negative ion is called as anion. Anion means negative ion. So during electrolysis, anion moving towards anode. Understand, children? At the respective electrodes, the ions are undergoing discharge. That is, it may either lose the electron or gain the electron. Clear? Yes. So remember the basic. Okay, yes. So in this electrolysis process, the cation is aluminium ion, the anion is oxide ion. Okay children, yes. So during electrolysis or during the extraction of aluminium from bauxite ore, the aluminium ion, okay, moving towards cathode and undergoing discharge. That is, at the cathode, the aluminium ion is undergoing reduction. Okay children, yes, this Al3 plus ion, okay, yes, undergoing reduction. That is, at the cathode, yes, the Al3 plus ion gain electron. Okay, yes, the Al3 plus ion gain the electron, okay, yes, and reduce it to Al. Okay ma, yes, remember, at the cathode reduction reaction will take place. Okay, at the cathode reduction reaction will take place. That is, during electrolysis, at the cathode reduction reaction will take place. Reduction follows gain of electron. Okay children, so the Al3 plus ion at the cathode undergoing reduction and gain electrons. Okay, yes, according to the balanced ionization equation of alumina, there are two Al3 plus ions are formed. So write the cathodic reaction for the two Al3 plus ion. So at the cathode, the aluminium ion is undergoing reduction. Reduction follows gain of electron. Okay, yes, and reduced to aluminium metal. Understand children? Yes. So here the Al3 plus ion gain 6 electrons. Understand children? Yes, it gains 6 electron and reduced it to aluminium metal. Understand? Yes. So the reaction occur at the cathode is 2 Al3 plus 6 electron gives 2 Al. Understand? Yes. So this is the balanced equation taking place at a cathode. Let it be equation number 2. Okay, yes, here Al3 plus ion will be in the molten form. Okay, yes, then aluminium, okay, it will be in the liquid state. Yes, so the cathodic reaction is 2 Al3 plus 6 electron gives 2 Al. Similarly, the oxide ion, okay, there is the O2 minus ion, okay, moving towards anode. At anode, yes, oxidation reaction will take place. Okay, yes, here we know oxidation involves loss of electron. Okay, yes, so here as per the balanced ionization equation of alumina, there are 3 oxide ions are formed, isn't it? So write the anodic reaction for 3 O2 minus ion. Okay ma, yes. So at anode, the oxide ion is undergoing oxidation. Oxidation involved, that is, it lose the electrons, isn't it? Okay, oxidation involves loss of electron. Okay, yes. So the 3 oxide ion is totally losing 6 electron and becoming, yes, 3 oxygen atom. 3 oxygen atom is equal to 1.5 molecule of oxygen. Okay children, yes, but the equation should be given, okay, with, yes, whole number only. So we can write the anodic reaction as 6 O2 minus ion gives 3 O2 plus 12 electron. Okay children, yes, 6 O2 minus ion, that is 12 electrons will be lost during oxidation. Okay, so 6 oxygen atom will be formed. The 6 oxygen atoms combined and evolved as 3 moles of oxygen. So what is the anodic reaction? 6 O2 minus ion gives 3 O2 plus 12 electron. Okay children, yes, here the oxide ion in the molten solution. Okay, let it be equation number 3. Okay, yes, here carbon, okay, carbon acts as anode. Okay children, during electrolysis, that is oxygen gas is evolved at the anode. Okay, so the oxygen gas evolved at the anode, okay, may oxidize the carbon as carbon monoxide or carbon dioxide. Understand, children? Yes. So since carbon acts as anode, okay, the following reaction also takes place. That is, here carbon is undergoing oxidation. Okay. Yes, and is oxidized to carbon monoxide. Okay, or carbon dioxide. Yes, actually here the carbon rod is, what is that? The carbon block, okay, is undergoing burning. Okay. Yes. Clear? Yes. So if carbon is oxidized to carbon monoxide means the equation for the oxidation of carbon to carbon monoxide is C plus O2 minus gives CO. Okay, with the loss of 2 electron. Carbon is oxidized to carbon monoxide by the loss of 2 electron. Okay, so the equation is C plus O2 minus gives CO plus 2 electron. Let it be equation number 4. Suppose if carbon is oxidized to carbon dioxide means, yes, the balanced equation for the oxidation of carbon to carbon dioxide is C plus 2O2 minus gives CO2 plus 4 electron. Okay ma, yes, here carbon is oxidized to carbon dioxide by the loss of 4 electron. Let it be equation number 5. Yes, since carbon, there is the carbon, okay, anode is completely burnt into CO2 gas. Remember children, during the extraction of aluminium from bauxite ore, okay, yes, by Herald process, the carbon anode is completely burnt into carbon dioxide gas. So the carbon block is removed, okay, periodically. Remember, okay, yes. So since the anode carbon is completely burnt into CO2 gas, the net electrolysis reaction is written by combining equations 2 and 5. Yes, the net electrolysis reaction is written by combining equations 2 and 5. Okay children, yes. Now we can see the net electrolysis reactions. The net electrolysis reaction is written by combining equations 2 and 5. Okay, yes. To equate the electrons, the second equation is multiplied by 2 and written. The equation is 4Al3 plus 12 electron gives 4Al. Okay children, yes. For Al3 plus ion you write melt, and then for Al you write L. Okay ma, yes. Then the fifth equation is multiplied by 3 and written. Okay, yes. The equation is 3C plus 6O2 minus gives 3CO2 plus 12 electron. Okay, if we combine and write these two equation means, yes, the net electrolysis equation is 4Al3 plus 3 carbon plus 6O2 minus gives 4Al plus 3 CO2. Yes, children, did you understand how to write the net electrolysis reaction? Yes, it's okay. The net electrolysis equation is 4Al3 plus 3C plus 6O2 minus gives 4Al plus 3 CO2. For Al3 plus ion and O2 minus ion, you write melt. Then carbon is in the solid state. Then aluminium it is in the liquid state. Then CO2 it is in the gaseous form. Understand children? Yes. So during electrolysis, metal. Okay. Yes. Metal will always be collected or deposited at the cathode only. Okay. Yes. Remember this point. So the pure aluminium is formed at the cathode and settles at the bottom. Yes. That's all about the electrochemical extraction of aluminium by Herald process. One of the possible 5-mark question.